Let's start our time today reviewing how to solve linear equations. So take a look at this problem and see what you can do with it. Now that you've tried for yourself, let's see together. There's something here. There's actually two somethings that hopefully stand out to you that look like it's going to make this a little more challenging. And what I'm referring to are these two fractions there. But they have something in common, don't they? Something very familiar, common denominators. And if it helps you, maybe just write these fractions on the side and ask yourself, what could I multiply these by to get rid of that denominator? Well, 3, right? If you multiply this by 3, well, that's the same as 3 over 1, cross cancel, right? Same thing here. So with that understanding, we want to multiply by 3, but we can't just multiply one side of the equation or one part of it. We have to multiply everything times 3. So let's do it. Before we do, I'm going to actually show you the most common mistake. So what people do is they go here and they go, okay, the 3's cancel out, -2. Then they go here, 9 times 3. Then they go distribute again, -12y. And then continue on. Right there, right here is where the most mistakes happen. Let's talk about and show why this isn't correct. Okay? Let's, for a second, look at and focus on this part of the equation and ask ourselves what's really happening. Well, we know the -2/3 is touching the 9 minus 4y. That means multiplication is happening. And we know anything can be written over 1 if there's no denominator already, right? And if you were to multiply this across, well, wouldn't you have this over this? So you would have this here, right? And then if you were to multiply this times 3, those would cancel out, and well, this 3 goes into 3 once, 3 once. All you would be left with is this, right? So for that reason, we do not actually multiply 9 times 3 and -4y times 3. Make sense? Okay, let's go ahead now and work it out. So we distribute that 3 and we get -2 times 9 minus 4y. We can distribute to the +1. Okay, right here, that fraction goes away. You just have 1y. And multiplying just everything else out. This was really where we needed to focus and spend some extra time. Okay, so now from here, I'll just do the next step, but really that's the only thing we really need to focus on here. Because the rest, I mean, we're distributing, and as you can see, we're already developing a pretty simple looking equation because we only have one variable. It's to the power of 1. We're just going to isolate that y using inverse operations. So that's as far as we are going to go for this one. Now that we've reviewed, let's go ahead and look at our goals for 5.09 solving rational equations. We want to solve a formula for a specific variable. You've done this before, right? So we're going to solve for x or y or m or whatever the variable may be. You're also going to solve rational equations in this form. So sometimes they're going to look like this, where you have one fraction on one side of the equal sign and another fraction on the other. Okay? But sometimes, other times, you're going to have situations where you have rational equations that are not in this form. There's not just one fraction on each side. And you're going to know how to solve both very soon. Sorry, the lighting is a little off. There we go. Okay. And last but not least, we've talked about this in this class already, but you should know how to explain what extraneous solutions are and why they come up and find them. Okay? So we're going to start by solving a proportion. Everything here is very important. I would have this in your notes. This deals with solving a proportion, which is one equation on each side of an equal sign. If there's not one equation on each side, it's not a proportion and we want to make it one. But for this example, we do have a proportion, don't we? So you have to be familiar with that terminology because there's something very specific we do with this, and that is cross multiply. Okay, don't confuse that with cross canceling. Let's go ahead. We want to cross multiply. So we have 12 times x minus 3 equals, right? We're still dealing with an equation, equals, and cross multiply these. X minus 2, x plus 3. Okay, we'll distribute that 12 to the x and the 3. And here we can use FOIL or box method. I'm going to use FOIL. So first, outside is going to give us 3x. Inside is going to give us negative 2x. 3x minus 2x, well, that's just x. And then last, negative 2 times 3 minus 6. Hopefully right now you notice that we are going to have a quadratic. So it's good to get this set equal to 0, and I'd like to keep the x squared positive. Okay, so we're going to get 0 is x squared minus 11x plus 30. Now you've had lots of experience solving quadratics. I will solve this very quickly. But really, we've gone over what's new already. Okay? This, from here, moving forward, is not new. So we're going to use the x method, a times c, then b, and you should find negative 6 and negative 5. So we're going to get factors of x minus 6 and x minus 5. So our answers are 6 and 5. And it's a good thing we actually did solve this one all the way because part of our goals today, we just talked about, is checking for extraneous solutions. Remember, those are solutions that don't actually work. So remember, just because we got these answers doesn't mean they actually work. So let's check them right now. Okay, x equals 6, so 6 minus 3, 6 minus 2, 6 plus 3, and then just 12. So we get 3/4, 9/12. Well, you divide that by 3/3, and you get a true statement. So, x equals 6 is actually a solution. What about the other? Let's see, we have 5. I'm going to write pretty small because I'm running out of space, but 5, 5, 5. There we go. So we get 2/3. And we get 8/12. Well, look at this. If we divide this by 4/4, we get 2/3 is equal to 2/3. That is also a valid working solution. And we like that. I mean, if it's not, it's not. But hey, it's good to know that we found some actual solutions. Now, take a look at this and maybe use your notes from previous lessons to help you we want to solve this, but first, is this a proportion? That's the key question here. We just talked about this. You just wrote this down. Let's go back to it as a refresher. An equation with one fraction on each side, only one, is called a proportion. While here we have one fraction, but here we do not, right? We have one. Technically, we have two, because you can write one as 1 over 1, can't you? So we need to focus right now only on this side of the equation. So let's take it apart. Let's just put it right here and ask ourselves, how can we make this one fraction? Well, we're adding, aren't we? And we have experience adding fractions. We need a common denominator, so we need a fancy form of 1. So q over q multiplying by that opposite denominator gives us this fraction. So we have 4 plus q over q, right? All right, so now we've created one fraction on that side of the equal sign. So it's time to bring everything back together. Equals 4 plus q over q. All right, now we have a proportion. What do we do with proportions? Cross multiply, right? So there we go. Q plus 3 times 4 plus q equals negative q. Okay, negative q, of course, comes from multiplying across this way. Now, we again are multiplying two binomials so FOIL or box method. The first two terms for q. First, outside, inside, last. Now that's an interesting one. Things are out of order. That's okay. We combine like terms and maybe reorder. Put q squared first. We have 4q plus 3q, and then our constant 12. And then we have that minus q still hanging out. So let's get that on the same side. I'm going to write my answer up top here. So we have q squared plus 8q plus 12 equals 0. Quadratic leading coefficient of 1, right? So X method should be our go-to strategy. There we go. Factors of 12. Let's see, we have 6 and 2. Well, those add to 8. That was easy. So what do we have? We have q plus 6 times q plus 2. What do we need to do now? Check for extraneous. You got it. Okay, let's do that now. I am quickly running out of space. So as you practice solving for extraneous, I'm just going to move some things around to clear up some room here. And I'll kind of divide this so it's organized for you. We're not going to check for extraneous all day long, but for these first few problems, it's good to get in the habit of doing that. Okay, here we go. Let's check it out. Of course, this would give us -6 and -2, right? Set each factor equal to 0, solve for x. These are very simple, so it's just the opposite sign. And we're going to go back to our original equation, right? This right here. And we're going to sub and solve. We're starting with -6. So what do I get? -1 over -3. You want to add these, so you multiply this by a fancy form of 1. We do, well, I could actually simplify that first. So let's do -2/3 plus 1. Um, Obviously, these aren't going to equal each other, right? This is going to give us a positive 1/3, and this is going to give us a, was that plus 1? Yeah, oh, actually, that does work out. So we do have one true solution, -6. Now, what about the other? Let's see. -1 over. Okay. -1 over 1. What do we have here? 4 over -2, so -2 plus 1. So we get -1 equals -1. It works again. Wow, lots of good, valid solutions today. There it is. All right. We've practiced a problem just like this, or at least very similar, so now's a good time to practice for yourself. Okay, let's do it now together. You guessed it, not, we do not have a proportion, so we want to make it a proportion. Multiply times the fancy form of 1, which is the opposite denominator over itself. Um, and that's really all we need to do there. So we have -x, +2 times x, +2 times -2 over our common denominator. Combine like terms, we get x minus 4 over x minus 2. All right, we have a proportion. Let's write it out. X minus 4. There's our new and improved fraction on the left. Now, I don't know about you, but let's see. Do you want to multiply x minus 4 with this? You can. You could use the box method and you could do 2 boxes by 3, like this, 2 rows, 3 columns. But let's see if we need to do that. Let's see. I would start by using the x method again. So let's see, 4 and -4, does that work out? Well, that's pretty straightforward. -2 and -2, that works, right? So we have x minus 2, x minus 2. Okay. Well, let's see what we can do now. If we cross multiply, we're going to get x minus 4 times x minus 2 times x minus 2. I need to move this because my boxes are in the way. Equals 24 times x minus 2. Interesting. What do we do with this? Well, in all honesty, it is looking to me like the box method is the best way to go because here, ultimately, everything's going to need to multiply together, right? So let's do it. We have a binomial times a trinomial. That was, I'm just going to rewrite it as it originally looked now. Okay. And this is good. This is kind of the thought process you should be going through. You're not always going to lead to the fastest way right off the bat, right? And that's okay. So here, let's see what we get. Okay. So I'm going to get, this was cross multiplying these two, right? So on one side of my equation, I'm going to get this. Let's see, we had 16x plus 4x, and then minus 16 equals, let's see, 24 times x, and then 24 times -2. Okay, let's combine like terms and see what happens. So we have a cubic function still. We're going to get minus 4x plus, what is that, 32, I believe. Okay, well, we have four terms. Factoring by grouping might be our best friend. Let's see. Um, you know what? We could do that, and most likely it will work out, but as I'm working this out, I'm thinking of a new, faster way to do this. So let's save some time, shall we? I'm in the business of helping you save time and do things in the most efficient way possible. So let's go back to this. And let's just show this again. I have this fraction over this. And we'd already factored this quadratic, didn't we? So the best way I'm seeing is to get these to have a common denominator. And you'll see why in a second. So we're missing an x plus 2 over here, right? And here's the reason. If you can get all of the fractions in a proportion to have a common denominator, you can get rid of all of them. Pretty nice, right? And it goes back to the idea of what we said before. If I multiplied everything times x plus 2, well, wouldn't all of these cancel out? Yes, they would. So that's what we're going to do. We're just going to cross those out. What a relief. We don't have to use the box method, factor by grouping, none of that. We're just going to do a simple FOIL here. So we get x squared, then outside negative 4x minus 2x. There we go. And then last, negative 2 times negative 4 equals 24. Now it's coming together. 8 minus 24. There we go. That is a more friendly, simple looking quadratic, isn't it? So let's try our x method one more time. We're going to get negative 16 over negative 6, and you will find that negative 8 and 2 work. So we did it. We found x minus 8 and x plus 2 to be our factors. Solve each for x, you get 8 and negative 2. We're not going to check for extraneous. You know how to do it. We've done it before, and we spent quite a bit of time on that one. So, trial and error sometimes, right? Trial and error, but now you know the fastest way. So, extraneous solutions, there is a quiz question that asks you specifically about extraneous solutions. So be sure you know how to recognize them and why it's extraneous. How? We did it before. You substitute your answers into the original equation one at a time and see if it equals each other or not. Is it a true statement or not, right? And what does that mean? It means it doesn't work. It's not an actual solution. Now we are done for the day. There is a 5.09 quiz related to this. So study and take it when you're ready.